There we go. All right. I have no idea where, yeah, Scott probably doesn't want me recording the cloud. So hello everybody, welcome. We've got a little more than a half dozen folks here and people on the interweb as well. Basically we've got three presentations that I'm aware of. Davie's gonna talk a bit about the brake lathe. Shira is gonna share the Makerspace that she's been setting up since sort of early 2020. And then I'm going to give an update on the building plans. So we'll start off with the building plan since I got it up here. And then I think maybe we'll jump to Shira and we'll jump back to Davie. I'm trying to ice Davie out. Does that work okay for you to go last or not? Time wise? Okay, I wasn't sure. So let me share my screen here. And all right. So I don't have too many slides. Don't get too bored right away. You guys see that remotely? Hopefully. All right. So we bought this building about 4 years ago, if people don't know that. And we've been slowly renovating it as absolutely slow as possible. Mainly just based on our available finances and our ability to get work done has been really the limiting forces and factors. So about 2 years ago, we got occupancy. So occupancy is a legal definition of a space that meets all safety and compliance requirements, meaning you have a bathroom, you have entry and egress pathways. In Wisconsin, you don't have to have drywall hung and finished, interestingly. I know other states, Davie was talking about this, you have to have the drywall hung, mudded, and painted, otherwise you can't get occupancy. So differing states have different occupancy. So I'll talk a little bit about Wisconsin, but if anyone is in other states or ever lived in other states, these laws vary down to the municipality level. There's like federal and international building code, and there's state code, and then there's city code, and they all overlap in a variety of ways, which is really frustrating. So in short, we've been slowly working towards, over the past literally 2 years, we've been working on our building plans, and we just got them approved about a week and a half ago. So the conditionally approved is as good as it gets. The city conditionally approves your plans on the condition that they approved your plans. They will never give you like approved plans. It's just always conditionally approved such that they could revoke your plans if they ever wanted to, which is kind of ludicrous, but that's as good as it gets. And then you can see our occupancy. We're business group B, which is like the way that you define how the space is used. And then the other is this assembly group A3. And then the last is this UDC, which actually I don't know what UDC is, but in short, it's a residential R3 is what the caretaker's quarters, the apartment will be. So our building is now split into 3 legal uses, which is part of what took a while, is figuring out how to structure all these adjacent uses and how we need to do that for requirements. We have a number of people to thank. They thought lots to help us out. Fink and Horish is who did all of our structural engineering, all in kind. So that means that they donated all of their time for free. They've done the engineering of the floor plans, the second floor, the building like roof lifts. They had to re-engineer the whole building roof to verify that the system, when it was built in 1949, is current with today's code for the structural engineering portion of it. James Witter is our architect. He is not here tonight, but he's usually out either on a sailboat or wandering around here grabbing random tools to work on projects. If any of you live in Madison, he built the yellow submarine that was out on the lake for a while. He took a boat and then he built a big conduit sculpture and then put a yellow submarine covering over top of it. So he's very much into boats, but he's been generous enough to help us out with our building plans, also in kind. Larry Barton, who's at Strang, was kind enough to help us out with some of these occupancy issues. So the issue is, as you get into larger buildings, the occupancy and uses stack. And so we needed to ask someone whether we were doing the correct thing or not. And they were kind enough to kind of give us a courtesy review of our plans to verify whether or not we were indeed doing the right thing. And then Matthias and BIM is a drafting company working out of South America. And so they were kind enough to help us out doing all the drawings. We did pay them for their work, but they were the ones who ultimately drew up in 3D what's called a Revit file. So Revit's an Autodesk product. So we have a 3D version of the building, which is as accurate as we build it to, I suppose. So normally on a building, you create plans and then you tell your contractors to build to the plans. In our case, we're the designer and the engineering kind of know-how and the contractor, and ultimately who will use the building. And so it's kind of up to us to decide what level of tolerance that we're after for whatever it is that we're doing. Lastly, I was hoping Brian would stop over, but Brian Bussey's done a ton of the engineering drawings. So he's who's drafted all of the designs that were then handed off to the structural engineers to approve. So you need a professional engineering degree or a professional engineering license, I should say, in Wisconsin to sign off on building plans. And so we can do all the drawings in the world, but if you don't have somebody with a PE license willing to look at them, review them, and then stamp their stamp to approve them, you can't do anything with your designs or drawings. So in short, we have this fancy view, which is way too small, but I have a bigger view in a second. So the upper part of this is the second or the first floor, and the lower part is the first floor. And some of this has already been built out. So all of the gray lines on here are already constructed. And then the black things are all new. So in this case, kind of where we're sitting is about here. This front entry area is going to get turned into like an event space or a lobby, and that's that assembly use. So when you submit plans, if you call a thing like an event space, then the city wants to know like what are you doing in there and how many people are you going to try to like squish in. And then there are code like legal requirements for how many people you can squish into a space and how many they expect you to squish into a space. So in this case, this front area of our building, they would expect that you can fit in 152 people in this space, unless you have like fixed furniture that would restrict that number of people from fitting in there. So that means once you've established your square footage and how many people fit in a space, you have to design then the exiting, and in this case, like sprinklers and things like that to match up with the code requirements for that many people, and that's that amount of space. So it gets complicated really fast, but you can dig through all the code and read it, and you can find code to look it all up. But in short, these different occupancies or different uses then trigger different requirements. So sort of the things to do downstairs are we're going to end up building out a classroom space in this upper right corner, kind of where the computer lab is. This event space will get walled in, which just kind of ties into the kitchen. The kitchen is now declared. It used to be a break room. So again, on your building plans, you can define different things, and with them come different levels of code compliance. So if you call a thing a break room, then you don't have to meet full kitchen code. But as soon as you call a thing a kitchen, then you need to put in a kitchen exhaust hood. So in this case, there's a small line here that says that we'll follow NFPA, which is National Fire Code, for having a kitchen and a stove and things like that. So there's lots of fun code things that come with the different implications of different wording. And then there's two kind of meeting rooms and like a reception space that'll get built on the front, as well as sort of this airlock, so we aren't letting tons of cold air in every time the front door is open. Other than that, the first floor remains mostly intact. There's some notes on here about some changes to some of the columns down this way, and then adding in a staircase in the back and a staircase in the front. I guess are the two other big relevant things. There's also an exterior staircase down here, and that'll be off of the deck. And that's not a legal requirement for that egress. So we can build that a little bit different than you would otherwise. Upstairs then, there's basically the right half of the building will get split into office space. The left half is storage, which is east and west respectively. There'll be a bathroom space, an elevator that we have to add in. And then you can see there'll be a deck outside on the south side of the building with a staircase coming down. And then the southwest corner is called the caretaker's quarters. It's like an apartment space. The interesting part there is, so Heather and I live there for now, and then down the road, we could use that potentially as like either a leasable space, or as you could use it as a space for somebody to like have a sabbatical, like from a company. So you could charge someone to come and live here, take care of the space, but also work on projects or give classes or presentations or whatever it is. So this is what the deck will look like on the south side. We got all these trusses donated from Findorf, their old roof trusses. So the joists that are kind of making up the deck surface here are old roof trusses. And then there's some tubes that we have to buy to make the legs. And then this will be up at the second floor height. So it should be kind of fun. And then lastly, there's some stuff that I'm working on now, which is we're splitting the second floor in half, which we originally designed to be able to do this, where the second floor has an 18-foot ceiling. And so you can split it in half into two 8-foot ceiling spaces. And so we're doing that first in the apartment area to make a loft. And so this will be a 400 square foot loft above what is the second floor above us now. And so we designed this to bear on the existing columns and beams that are there already. So you can kind of get a sideways view representative of what that would look like. Down the road, we could add another 6,000 square feet onto the building by building a loft down the middle of the building upstairs and splitting the level in half. And when we did the footing calculations and the beams and everything else, we designed for having another half floor above us. So we don't have to cut the roof off and lift it again. We can leave it where it is and still get a little bit more space. So that's it. Oh God, Davie.
So you can't go full width with a mezzanine or a second story, a third story?
No,
because of the arch?
so the question Davie had was, can you go full width? You could up to a point. I forget what your headroom clearance is. You can have a certain percentage of your headroom occluded by overhead, like in a house where you've got a roof coming down. I don't remember what the code is. Sean might know offhand, but there's some percentage of your ceiling space that you can go under what would be legal. Yeah, you could do like storage or something on the edge of it. But yes, in short, Davie's question is, can you go full width? And the answer is no, you couldn't, and nor would it be worthwhile, because at some level you wouldn't be able to use it for anything. Other questions, anybody? Shira, go for it.
I think I might have missed it, but is there an elevator?
There is an elevator. Yeah, so the elevator I didn't talk about much, but yep, it's right up on the top right of the picture here. So the elevator plans get submitted separately, and that's one thing that we cannot build, nor can we buy one from Alibaba or eBay or anywhere. You can buy one online, and they're about 10 grand. It's actually really cheap, and it ships to you in a big shipping container. And I've talked to a company about it, and it's like $12,000. And you get it, and you literally have a crane tip it upright, and you bolt 4 bolts in the ground, and you plug it into a 220 outlet, and then it's an elevator. And that's it. And I said, well, great. Do you guys have any installers who can install it for us in the US? And they said, you don't need an installer. It's 4 bolts and a plug. And I said, no, by code, you have to have an installer in the US, so you can't do it. And they're like, yeah, we don't have anybody who does that. So there's lots of companies internationally who manufacture elevators in places that there's less building code, and then they can put up an elevator wherever they want. But in this case, for here, we can't do things like that, which probably good, might be bad, hard to tell. Depends on who's installing the elevator. So Sean's question is, the elevator required for equal access upstairs? And the answer is, yeah, the elevator is required not for egress, but for ADA compliance. So if someone's in a wheelchair, they need to be able to get to the 2nd floor. We tried to avoid that by looking into whether or not we could take the 2nd floor and mark all of it as storage or residential, and then only have 3,000 square feet or less as a business use. And if you do that, you could be exempt from the ADA code, because if you have less than 3,000 square feet, you don't have to build an elevator to reach it. But it turns out the people who wrote ADA code at a federal level are very smart, and they realize people are going to screw with things and try to do that. And so the way that they count your 3,000 square feet is actually by floor plate area, and they don't care how you use it. So even if you have 1,000,000 square feet and it's storage, and you have 3,000 or 300 square feet as whatever else, you still have to build an elevator to it until the floor plate itself is smaller than 3,000 square feet. So you cannot avoid putting an elevator at all. There's no way to do it.
So what does that?
Yeah.
What does that mean for if you were to go to another floor? What's the requirement for a floor?
So Mark's question is, if you put another floor on, or do you have to put another elevator? As soon as it goes past 3,000 square feet, you do. There's some weird things on lofts. So technically you might be able to loft a portion of it and then have that portion be small, and then loft another portion of it, and then loft another portion of it. And you could stay underneath the floor plate because it wouldn't be contiguous. So there's some tricks there. So like if our 2nd floor was truly broken into 3,000 square foot blocks, you might be able to exempt yourself that way. But obviously your usability goes way down when you have separately accessible 3,000 square foot spaces. You'll see this when you start looking for it in like manufacturing buildings where they've lofted above an office component. You'll always see where the lofted area is always relatively small relative to this massive building with a massive office space. And that's specifically to stay under this access requirement. So interesting, clever stuff. Mr. Brian?
What if you were making the 3rd floor, you widows walk or deck? Open air deck.
So Brian wanted to know, could you make the 3rd floor like a mechanical access, a very large mechanical access? And the answer is, yeah, you can do some things like that, where if it's mechanical access, but you'd have to justify how it was, like, why is that mechanical access and not usable square footage? So some of it's subjective, and a building inspector could at any point, which is part of the conditional approval on your building plans, that's like, oh, we could just conditionally remove your approval because you lied to us about what you were doing. So things like that. That's kind of why they do that. Mr. Davie.
Two-part question.
Oh no, no.
You use the word egress a bunch of times, but I don't really know what it means. I don't even know what it means.
Yeah, so egress is just a legal means of exiting.
Oh.
So like an egress path would be like, you're upstairs, you want to get outside. How do you do that? And how do you get where you want to go? So in this case, we have two means of egress. There's a stairs here, which would be called a protected means of egress because it's boxed in with drywall, 1 hour rating all the way around it. And this is an unprotected egress here on the right side because there's no box around it. It's just open staircase down. There are some legal requirements for when you can and can't do either of those things, which I know a lot about. This south side deck is the same thing. This is not a legal means of egress, even though you could certainly use it to leave the building and by code all the stair widths and all the stuff for compliant. But it's not in a legal spot to be used as a means of exiting. So the ideal situation is we would use this east staircase and the deck as our exits, but we had to put in this west staircase for a couple of reasons, and so it made sense just to put it in there. We're trying to not put in a staircase there, but there's a reason we left the concrete out, and it was against my suggestion because I wanted to not put that piece out and cut it down later. But it was good that we did because we ended up needing to do it. So, oh, Sean's got it, or Davie's got his quarter still on the pool table here.
Anyway, so can you be a super dick and do a ramp around the inside of the building instead of an elevator?
So Davie wants to know, can you build a really long wheelchair ramp? Also looked into it. It needs to be the entire length of the building and then another little bit to get up 14 feet because you can't ramp continuously. You have to have rest areas, and the rest areas are pretty frequent. So yeah, I definitely looked at, could you build a really long, or could you just berm up dirt and like figure out some way to like, oh, you can drive up to the handicap accessible spot up there and then park and then get out and back grade. But no, yeah, there are smart people who've thought through all these things and how you can mess with stuff. But you do occasionally see on buildings that have a really long accessible ramp, and that's why they have to do that, where it zigzags back and forth a zillion times.
Yeah, I think it's 30 inches of drop in elevation. Well, I've always got all this headspace. I just like, exactly that. I'm not advocating for that.
You guys are the reason all this code has to exist. I have to read thousands of pages of code because people like you, Davie.
So I guess, the only other thing that I know this is regarding, find the guy conditional approval.
You keep your mouth shut. I don't want to know where you're going.
Well, you need a $30,000 whatever elevator to have access.
70,000, yes. Yeah, 70.
Can't that be a means of egress?
No, because so Sean's question is the elevator count as a means of egress? And the answer is no, because in the event of a fire, you'd lock out the elevator. In fact, if the fire alarm goes off, you shut off the elevator because you don't want to trap somebody in the elevator. It turns out when there's fire down below and the elevator shuttles you from here down to here, and then doors open and it's all fire, and then you can't get out, but you can't go up anymore because the hydraulics have burned or who knows what. That's all bad. So they actually would rather have somebody who's disabled sit at a staircase waiting for somebody to come save them, rather than put them in an elevator that may or may not lead to them dying. So also, once you're trapped in the elevator, it's hard to know if anybody's in there and where they are in the building. So obviously here it's an exception because there's only 2 stories. But if you had a 12-story building and somebody went in an elevator and it went partway down, you have no idea where they are or anything else. So it would suck to be in a wheelchair and having looked through this code, because literally it'd say, oh, just, gather people in wheelchairs over here and we'll hope that the firefighters get there in time to help them. That's not great. Other less depressing questions? John?
As you went through this, I imagine you had a budget you were wrestling with. Can we do this, not do that thing?
No.
No?
Well, no, we're building all the stuff ourselves, so that doesn't really matter. That doesn't matter.
Secondly, knowing how it's taken, what's your estimate before you build that occupancy second floor for office?
The occupancy restriction on the second floor is a couple fold. The most important one is the egress. So we need to get both staircases built. And then you can't get occupancy until you have the elevator. And I would say at this point, getting occupancy in that regard isn't a super high priority, as we have plenty of space down here to do whatever we need to do. We can eat the rest of the space for office space if we needed to or whatever. So in short, I don't know. We'll plug away on things as it makes sense. And the elevator will make more sense to do. We could either work hard this fall and dig in the foundation and get it set up, or we could say screw it and do it in spring, depending on what we want to do. But we have to set down a full frost wall, foundation wall around it, and then build that up. And pulling up the footing requirements.
So can you give us a high level punch list of how this is gonna go as far as like elevator, cap, or outside walkway, apartment, all that stuff?
Davey's trying to squeeze me on what order we're going to build things in so he can somehow hold it to some type of a timeline. I think that's his goal anyways. I have no idea. Obviously the easiest one to get code compliance with over the winter is going to be the apartment because everything's built indoors.
Yeah.
But the hardest one was going to be getting an external contractor. As hopefully we've learned by now, external contractors are super unreliable. And you'd think that they'd be fast to complete their work, and they often aren't. So I think getting the elevator boxed in and getting the foundation made is only the tiny bit of the start. And then getting a contractor to show up and actually install the elevator and get it done is going to be a whole nother.
So we'll skin it and then they'll install inside that?
Yeah, so we have to build an enclosure with a foundation. So that's the foundation. So it'll be very similar to what we're doing for our interior footings. And then, yeah, they work inside of the enclosure. And it's actually just a 2x6 steel stud framing, just like we did the exterior of the building. And then they want some spots put in with wood, evil wood stuff that they can lag screw the rails into. And then most of the load comes down and is bearing on this foundation. And so really the elevator is like a forklift because it's just literally a hydraulic cylinder going up on a rail. And then underneath there's a foot that comes out and bears on our foundation. And that's the reaction from it tipping over. It's not so much the wall, but more the rails and the joint at the bottom. So and they do all that engineering and all this stuff. Mr. Sean?
You're really talking like 3 projects.
We're talking like, yes.
Well, because you have
3
you have-
projects.
You don't get an elevator until you put it on the space.
Yep.
So as long as you don't put all the space.
Yes.
Oh, you can have caretaker quarters?
Yes. Yep.
Occupancy without
Yeah.
elevator.
Yep.
you
In
need-
fact, we don't even need the front staircase. You only need one.
Yeah, so it's like you need one set of stairs to get the occupancy for the apartment. And then the deck obviously
Is its own thing. Yep. And the deck doesn't help us with any compliance requirements, so it's the lowest priority. Although admittedly, I imagine you guys would be motivated to build the deck because it's a pretty sweet space to be on. But yes, the deck is not a huge priority that way. So yeah, that's yes. Sean, professional contractor Sean, obviously looks at lots of building plans and knows how to think about them and how they're relevant. Oh, I missed the chat question. Let's see here. Bob asked, no bathroom in the caretaker's quarters. Bob is actually looking at the plans. Nice work, Mr. Bob. There is a bathroom. It's on the split floor that I didn't show you. I think, let me see here. There's because that portion of it's lofted. Yeah, I don't have it in the pictures. Essentially, the bathroom for the caretaker's quarters is on the lofted portion of the floor. And I didn't show you the subset of that to make the plans bigger, so it'd be easier to see. Any other? Yep. So that Elliot asked how do you help with the building construction? So there's actually a construction mailing list, and I have not sent out any emails to the construction mailing list in about a year and a half. So it's gonna be really funny when I send out an email and everybody's like, I didn't sign up for this, and like, no, you did like 3 years ago. But yes, I'll be spamming out to the mailing list when we start doing things and go from there. So I showed you the building plans are approved, but we're waiting on zoning, the person in zoning to check a box that says our site plan is a totally different building plan set that I didn't show any of it, matches up with the building plans that we submitted. So essentially there's one more like half step to do. So we're waiting on this person to check a box and I can go buy the building plans. And then once we have those, we can have the construction inspected. Once it's inspected, then you can kind of move forward on things. So essentially you do framing first, and then you get the electrical and the plumbing and all that stuff inspected. Then you put your drywall around it, and then you do a final inspection on your plumbing and on your electrical and whatever else you've got. And then you try to get occupancy after that. So
To elaborate on this question, we usually do like ad hoc workers where, somebody will kind of figure out what you know and put you in charge of something that you can handle. And then, like these wall sections, we did, kind of beam to beam one wall section on a Saturday. And so like the first time you would show up, you would have no idea what you're doing. You have to give you a month, because then by the time you get 4 around, you're just the guy in charge of you doing your first wall. That's kind of.
for better or for worse, there's a few walls, it's just a little tilted, but it works out in the long run. Yeah, it's very much learn as you do. And that's the thing, is your standards are very much to meet your own standards. And so if our standard is like, well, we painted all the walls except for this one because there's like stuff to paint around, and we're all okay with that, then that's fine. But yeah, we kind of chip through things as we need to.
I was gonna say, all that being said, if you look back at some of the videos, what this really is, like, it's pretty much all volunteer. There's some things that are hired out, for sure, but it was impressive to see what it was.
All right, so Shira, are you oh, you're back. You want to take it away?
All right. Is there any way I can see the audience or no? It's all right if the system is not set up for that. Hi, everyone. All right. So we are in my makerspace. Oh, it has pretty lights. All right. So where are we actually? And who am I? And I guess it's been a long time. My name is Shira Epstein. I am the director of campus makerspaces here at UMass Amherst. But really, I'm a Sector 67 member who should have just stayed in Sector 67 because that's when someone else took care of all the problems for me. Thank you, Chris. And I didn't have to think about any of these things, and now I have to think about them all the time. So this building is the Astronomy Research Facility. It's our temporary location. Maybe I'll just kind of hop outside for a minute and give you a sense of it. So here we are on campus. Here's this like big metal building with a dent in it. Working on getting that dent fixed. All right. So this building, I should really start with the raison d'etre for this building. You're about to see it. We'll go back and cover ground later, but like, why is this building here? Why do we have access to it? Here we are, the big tube. It's a really big tube. So this tube, let's see if I can focus. Come on, focus. There we go. This tube extends the whole length of this thing. It just goes and goes and goes and goes and goes. And so this tube used to be part of the astronomy research mission of this building. And I guess down at this side or something, a Michaelson Interferometer was attached. There's some clues to that end. Firstly, I found the Michaelson Interferometer. And secondly, there's a big sign over here. This is Michaelson Interferometer. And there's also this drawing of how the machine would have been used that I found. So there's the Michaelson Interferometer or something like that, and there's the tube. And anyway, nowadays this building is used, I guess it's been promised to student engineering clubs, but kind of as we get started, as the Makerspace is renovating its future location, we have shared use of it with these student engineering clubs, and it's probably a good thing that we have shared use of it because the student engineering clubs could certainly use a Makerspace, right? In all kinds of ways. So in this area, we've set up like a little kitchenette, which is a little difficult now with the pandemic. Like all the rules keep changing every other week. So we had a moment where it was no masks and now it's masks again, except for when you're eating, except for in what's defined as a dining space. It's hard to say what, but we basically just eat outside now. And we have like an area for storage and for sinks, for washing your hands. The fact that there's water is good, but it's not really, it doesn't really taste that good. So we fill water from hydration stations in adjacent buildings. We have what I call the Magical Makerspace Mystery Tour. And that is an ongoing project to create a series of remote controlled things that will serve as a useful set of like emphasis I don't know, pluralize that word, for all of our various tours that we give here. So here's the first one. It's very silly, but you can see all around I've started to set up additional things. And it's just not all set up just yet, but it is helpful. I can tell that it definitely works for giving tours to a number of people, especially a large number of people all at the same time. We've got sewing machines, we've got all kinds of crafts, just a very large mess right now, but we're working on that as fast as we possibly can. Oh, and here is a Corsi Rosenthal box. So that someone assembled today. It's, 4 filters and a fan. And I want to see if in a week it looks very dirty, because then that, I guess, to me, that means it worked. The rocket team meets here. They have a lot of rockets. So we try to be creative about mounting them higher and higher up on the wall so we can make room for future rockets. We have a little exhaust over here for working with things that you want to leave to off gas overnight with the air running out. We have a vacuum oven, a fancy one that I still need to put through its paces. Dress forms, storage, and then a main workshop, which is like the big part of this room. Look, a Quonset hut. It's right now, it's like, okay, so these fans are very loud. I'll turn them off. There we go. A lot of box fans. There's not really air conditioning here. It's a little bit quieter now. We have the largest 3D printer on campus. It's currently down for maintenance, but like just in time, just my like perfect luck, a student walked in a couple days ago and it was like telling me what I needed to do. And I was like, no, you're hired. Come here and fix it. You're gonna do it tomorrow. So that's what we have going, is all of these printers are about to get a lot of much needed TLC. This is how I get stuff to the Makerspace. I rent a truck and I bring it here. I need a truck. This was the only way to get shelving quickly. Everything, if you're familiar with the pandemic, it's been back ordered pretty significantly. And so it's been a real tough time getting anything. Tomorrow I have to go looking for something that was delivered somewhere on campus, but nobody knows exactly where. We've got this nice 5 horsepower saw stop. We have our dust collection system, which is like a temporary fix, but we're gonna work on making that more permanent and eventually bring in a plumbing inspector, like whatever is required, not a plumbing, like the ductwork, the state ductwork inspector is going to approve our future ductwork. It's a lot of code to even just allow us to run this temporarily. Ask me once how I spent like most of my budget on a fan that we never used. Anyway, I've got bandsaw, the drill press, the miter saw, sliding compound miter saw, scroll saw, a bunch of stuff in brand new tool carts. And yeah, that's like the quick version. Our neighbors on this part of the building are the super mileage vehicle team. They do really cool stuff, but I don't know exactly what's involved. There's an engine in there. And it's definitely undersized because there are a lot of students here. And it's like, working like 12-hour days to try and like do at least a little bit of what I need to do. But it is fun. It was very fun. That's all. Oh, I'll show you the cool thing I found. So on campus, we have a lot of like very large collections of mysterious old research items. And a lot of people feel bad about throwing them out. So they'll be like, hey, come take a look at like this fastener selection from the 1950s. I'm sure there's something the Makerspace needs there. And there's always something really fun to see. And so I like to look at, okay, so this is a pop quiz, or I guess, I don't know, just a question. Does anyone know what this is? So I'll tell you what it says. It says Aeolux American Optical Company Space Defense Division. They went bankrupt in like the 1980s. And then it's a very long box. It looks like a kind of a box you would expect like a wand from Harry Potter to come in. And inside is something that appears to be like optical in nature. It feels like glass and it turns purple when you go outside with it. But under the fluorescence, it looks blue. So if you have hypotheses about this, tell me.
I have a regular question. You use the term we a lot. Is that the royal we, or do you actually have a staff?
I have undergraduate student staff who work with me up to about 20 hours a week, usually like 10 to 15. But it's sometimes I am the makerspace.
Is this a permanent space or is it just temporary while your other space is broken?
Right. It's temporary. The renovation for the new space, we're calling that our permanent space. I like to be even more optimistic and imagine that that's temporary too. But for donor reasons, that's our permanent space. And it's a lot. Once it's renovated, it'll be really good. For the university of the size that it is, it may be a little tight, but it will be a good space.
I have a guess as to what your device is.
Okay, I'm all ears.
I believe that's a 1064 nanometer YAG laser rod. And I bet if you put a strobe light and you strobe the shit out of it, you'll get a laser out of the end of it. Don't put your eyes on the small end. That's my guess. Because that would be a purple rod. And that's what you would do with it. It's just a glass rod and you strobe the outside of it and then it generates laser on the inside of it. So I bet that's what it is. And that's a really, really big one. So you could make a really big laser out of that.
That's awesome. All right, I will start doing some additional searching to confirm that.
Yeah, if you look up purple glass rod laser, that's exactly what it is. You'd have to know it was a laser though, because if you look up purple glass rod, I'm sure you get all sorts of results, but the laser's the trick. Oh, Bob says ALX has the patent on glass laser rods. There it is. The power of the nerds. Yeah, it's kind of funny you said it changes color on the sunlight. I wonder if there's enough emission to actually be generating anything internally. I'm not sure. You have to look and see.
I did keep the end caps on, so hopefully have.
That spectrum you have to be really careful with because it goes through your glasses as optics and it burns the back of your retina, not your cornea. And so you have to be super careful because you're permanently forever blinded, not like really expensive surgery blinded, but like blinded. So be careful. I say that as someone who has a 500 watt YAG laser sitting here that we have to safely get into a box and be able to use it without blinding anybody. So, and it's also invisible, which is super helpful. And you have other questions for Shira? You can shout at the ceiling, ironically. That's where all the microphones are.
So, Shira, is this open to any student on campus, or is there a membership involved?
Yeah, I mean, membership is about training, right? It's about someone writing their name down, basically. And obviously, training is like levels and levels of training, and it's an ongoing target to try to like figure out how to keep track of everything. But yes, like the goal is to be an interdisciplinary space where students from all majors can come in, because right now there's a very large network of really cool spaces, but they're basically all disciplinary with a couple exceptions. So you end up with a lot of students who will be taking a class outside of their major and then like discover a space that they can only use for the purposes of that class and never come back again or something like that because it's not in their major.
How many students do you have potentially to work with?
Well, I mean, the whole campus might come visit, right? But
yes, that's my question. How many
that's where I was
students?
going with it too. Like, how do you do that to sign up time to use, like use table saw or learn how to use the 3D printer?
Right, so we haven't done too many workshops yet, like general purpose workshops. And there's ways of controlling the demand for workshops. Like an easy one just to dampen demand is put it in the middle of the day because, you know, students want to do stuff in the evening. So basically it's kind of like feedback loop, right? If too many people sign up, we start to put like enrollment caps on stuff or start to reserve or schedule things or like, you know, restrict some areas of open hours for student clubs who have already asked to meet there or something. But it's basically like we're just feeling it out because the campus is still learning that this exists, and it keeps moving. Like this is the second location and we're moving back to the first location. So we just keep hopping around campus, and like as people find out about us, explaining how much help we can give or how we can give help or who can be here, this, you know, how many people can be here. It's all kind of just moving around.
Any other questions? Are you having fun? Sometimes?
Sometimes. I'm very tired, but I am having fun. You know, like there's it's a mix, right? Every day there's that moment where, something really fun happens and, somebody shows up to show you how to fix your 3D printer and you have like absolute faith that they can do it. And then you can kind of rest assured and do something else. But then that something else ends up being like, calling a trucking company for the millionth time to ask if indeed the order will be delayed one more day. So it's just a big mix of different things. It's a roller coaster of emotions every day.
I'm very familiar. I just thought for the audience, they might want to know. That's awesome. How's Scott doing?
He's doing well. He just finished his sabbatical.
Nice.
So he's back to teaching.
Maybe not nice.
So
Well, no, he loved it.
oh, I'm sorry, I had are you in charge of any like curriculum or reporting to, or like kids to like, or is this just, for lack of a better word, like a fun space for the kids to go and dig around in?
My goal here is for it to be both an academic space and a research space, and like, for undergraduates doing research projects, but also a personal project space and student club space. So during the day, I try to get as many courses to take place or to come visit here as possible to really tie the academics to this space. And there's a bunch of ways in which that's happening. And one of the ways is that I teach a class, introductory seminar for students in their first year. Here in the Makerspace, the goal of that seminar is always abstractly, like, because a lot of instructors teach these, to get students familiar with campus resources and set them up for academic success in their four-year journey here. And so my goal with making a seminar focused on makerspaces is to bring in a bunch of first-year students and really give them like the tools for success if they are interested in making something here on campus. And that's also understanding where the rest of the resources are on campus and how to access those. But there's also a number of other classes that either take place permanently in here or visit like at least a couple times a semester for a field trip and send their students here to do their final course projects. And so I think by tying all those things together, really making the case for the makerspace a lot stronger, that's the goal there. If you look around at any university, I bet you'll find a whole bunch of design projects and courses that are taught in like kind of weird classroom spaces that weren't intended for that kind of use, and like chemistry labs that have been like turned into other types of spaces, and classrooms that have been turned into other kinds of spaces. And my goal is to kind of help provide the right kind of space for those projects so that it's not always ad hoc, and then to hopefully make the claim that we could build it even bigger.
Mark? Are there other makerspaces in other UMass campuses? Or is it?
There's a makerspace at UMass Lowell that's pretty impressive.
And is there then a network of use, or is there a similar person in these other places?
Well, so the best of my understanding, the biggest upcoming connection is that UMass acquired what they call the Mount Ida campus right near Boston, and its primary intent, I think, is, if I understand it correctly, is a lot of our students will do co-ops and internships in Boston, and so the Mount Ida campus is a way to be closer there, and it primarily serves, as I understand it, U-Mass Amherst. So there's definitely interest there in kind of a makerspace in that location, and maybe a lot of future tie-ins. But right now the distance is, there's so much to do just right here. And the students themselves, right, they're going to travel in a very, you've noticed this with the UW students, but they're going to stay pretty close to their dorm room and their engineering lecture halls. So I haven't really had a chance to really explore that part yet.
Is you guys' enrollment really high this year? I know UW here in town has like nearly double enrollment because everybody who deferred last year and then plus everybody who graduated this year.
Yeah, I didn't look at the numbers, but I've certainly been hearing that all of the resources, including parking, is sold out and the dining halls are overloaded. So I think that that's true.
Any other questions? All right. Thank you, Shira. I can't believe nobody pinned you down on when you'll be here next, but it sounds like you've got your work cut out for you for a while. We're going to hand it over to Davie for the last presentation here. I'm going to Yeah. Let's do this. I'm just gonna put it over on there.
Yeah.
Because I don't want to change my video layout while it's running, because I'm afraid Zoom's gonna crash. But let me share this screen here. All right, so you guys should be able to see that on Zoom, I believe.
I'm gonna put this back up here so I'm not, we're looking at like, they're looking at your chin.
Oh, it's perfect. Look at your chin. It's because you're tall, doesn't mean.
What, is it gonna fall
Let's see
down?
if we can break everything. There we go.
Hi, okay. So as with any good story, this starts with $1,000. My little brother bought a $1,000 car, which today means basically nothing. So this is an 06 Ford Taurus that has a myriad of problems, starting with which the brakes are shot. And so Chris used to have this big brake lathe that I always want, you know, like when I worked at O'Reilly's in high school, there was some guy that did that all day and I always wanted to do it. And I finally got a project to do it. And then he told me he sold it like a year and a half ago. And so I got stuck with the gimpy little brake lathe, which I'm going to tell you about. But to give you a kind of a primer into the what like we were working with, we got his car in here and we got on the lift and we started to pick it up and we got about 3 feet in the air and the whole car goes clunk and the frame started crumbling underneath like wherever we ejected up. So I had to get the expert help to move the points around and pick it up under like suspension parts that like theoretically were going to be stronger than this frame that was right next to that just crumbled. So anyway, so we got it out, we got it apart, and then this is what we found. This is actually the good brake lathe or brake rotor. The other one, the bad one, we were so bent on trying to get it fixed, I didn't even take a picture of it. So this is kind of what the other side looked like. This is this brake lathe. This is an on-car brake lathe. It's in the shop if anybody needs to use it. And so what you have here is it's a 2-part contraption. So this is the actual, the lathe tooling, and then this is the motor. And so you bolt this, and I've got a couple other pictures that I'll flip through, but you bolt this motor contraption to the studs that the tire bolts to. And then you take the caliper and the caliper bracket off and you mount the tooling end to that bracket.
And of course, we have good instructions for all this, right?
Oh yeah, and this was bought in like 1996 for like $75 on eBay. And so it really just came down to me and Chris just like digging around on the internet to see what other companies have done and kind of putting all the pieces together and going, well, this thing fits here and this probably goes there. So that was kind of fun actually. So you bolt this thing on. We figured out eventually to put them cattywampus so they center on the 5-bolt studs. This is you can kind of see there's this bracket here that took a lot of kind of figuring and ciphering, and I had to add my own bolts from the hardware store over there to get this the lathe tooling attached to the car. And then what I ended up doing, if anybody does this, this is the best I could kind of guess to do, is each one of these knobs here is the adjustment for the tool, the insert tool onto the rotor. And so there's another one on the other side. And so what I did is I put the brackets on and then left it loose enough to where it would slop left and right, and then slowly dialed in those knobs at an even rate and to where it kind of pushed its center basically and kind of watched it and moved it around. That seemed to work. I realized later, I think I could have pushed it all to one side because you adjust them independently. So this is automatic in that the feed of the tool across the surface of the rotor is a power feed, but then the actual bite you adjust with the thumb screws. And so you get this, and there you can see a little bit better of the kind of the bracket and how, and there's an identical bracket underneath the hook to the bottom caliper bracket bolt. So a lot of them kind of monkeying around. This rubber band here apparently costs $20 when you break it because we broke the other one. And that's supposed to be a vibration dampening thing. And so then this is kind of just to give you a quick idea of what the tutorial, the controls look like. I actually didn't get a picture of the motor assembly, but you can kind of see it here. You've got a switch for speed 1 and 2 and forward and speed 1 and 2 and backwards. And then you have a knob on the other side of it that is the feed rate knob for the tooling across the diameter of the rotor. I just got a job selling CNC milling equipment, so I actually fortunately had like a foundation of knowledge that really helped out in this scenario, which like 6 months ago I would have just like fumbled my way. It probably broke a bunch of stuff. And so here's this thing here. And so then this is what it looks like. So these brake rotors were super crusty. If we would have taken them to any like reasonable person, they would have just thrown them away and told us we had to buy new ones. But the definition of this project was cheap, right? We were trying to get brakes, get the car running for as little money as possible. I think he put $25 into some pads. The calipers are still jacked up and they still squeeze, and he's still heat treating his brake cal. You know, that's a whole nother ball of wax, but the car costs $1,000. It's also been recently downgraded from a V6 to a V5 because we broke a spark plug off in the motor, but that's just a whole nother ball of wax. Just to tell you what we're working with here. We wanted to get the car more functional. That was the goal of the day. And so then this is just kind of the controls here. It's fed, the connection between the two is this like 100-year-old, it was like a headphone jack cable. And so there were several times where I was watching it, it wouldn't move, and I would have to just wiggle this cable end, and then the light would come on. And then it worked. And so here it is running, taking the surface of the crusty surface off. And I took a billion videos. This is not a quick process because the motor spins and it just grinds away at it. And so there was plenty of time to dink around on my phone and talk to my brother and all this stuff. And so I took a few videos, but this was kind of cool because you can see I'll show you a different one, but you can see the difference. And this is full speed. And this is all just the crusty, rusty nonsense coming off. And you can see it building up on the insert tool. I'm going to see if I can do this because you don't really need to hear it all. But you can see the rust and nonsense building up. So we had to do several passes of rust removal before we could even get into metal to then like surface the metal. And so here's kind of just another, this is like a full speed shot, I believe, of what it looks like. But ultimately, it was a really cool process. And so once we did the one side, instead of moving the whole contraption to the other side, I just put the other rotor on this side and then, you know, surfaced it, which worked out really well. And this machine, for the record, is typically used when you don't have a full, you know, $20,000 brake lathe, or there's some cars that the rotor is pressed onto the hub and you actually have to turn the rotors this way, or like pull them, press them off and send them away and all that. And then just for fun, since I had all the time, I went ahead and got some slow-mo video, because what good is a presentation without super slow-mo? And so this was kind of fun to see. And this is even still like, and I got another one here. This is still in like the dirty parts. So you can see how the chips are all breaking up, and they're kind of just, it's nonsense, you know, coming off of this thing. There's like big chips and little chips. And then as you get into the, you know, here we've got a lot cleaner metal, and the chip kind of geometry turns a lot more consistent. And so, and then the whole time, the way this works is you dial in your, because when you need two parallel surfaces on a rotor so that your brakes don't, you know, get out of wonk. And then so we would feed it out, and I was actually doing one side at a time until I got to clean metal, and then I would do both of them. And so I would manually draw it in with the wheel that was broken off. And then when you turn the machine on, you spin, I would spin it slow for the first round for all this like crap removal. And then you turn on the auto feed at whatever rate you want, and that changes how fast it moves out and cleans the surface. And then you get one polished surface, and then you go, you know, and do it again. And then this is kind of what it looks like. You know, obviously the first one that we did against the old one, which was a magnificent difference, quite honestly. So it took the better part of 4 hours or something of dinking around, but we saved a boatload of money and we learned a lot doing it. What I kind of came to at the end after dinking around with this all day was the winning recipe was to keep it going slow to do all the removal, but then for the final kind of polishing. And then Chris said, like on the old brake lathe, there's different, you got to do crisscross patterns and flip flops and doodahs and all this stuff. We didn't have any of that. I just kind of figured it out as I went. And basically what I did was I ran it for the final pass to get like as kind of mirror surface as you can get, or as nice of a surface as I was going after. I ran the rotation of the rotor on fast and on number 2, and then the feed rate on the slowest it would go. And then I actually fed it out, and then when it got out, I changed the direction to feed it back in. So I did a double hit on that one surface at the same, I didn't adjust the bite. And I'm sure there's a bunch of technical terms that my boss would probably be crying if he heard me using these terms, but Yeah, yeah. Peter earmuffs. And so, anyway, so that's what I learned about the brake lathe machine. Any questions? I think
We can't do this on regular lathe.
because you need two parallel surfaces. And so getting your, taking a rotor off and rechucking it, and it's like kind of a recipe for disaster.
Kind of post-processing, you
Uh,
actually, reflect the carbon back down.
That's it. Yeah, new brake pads. I did warn my little brother is new to car ownership, and I actually warned him that you have to pump the brakes, which is I wanted to not, but we were worried that he would rail into the building or whatever. Because anybody that's changed your brakes, you squeeze all the hydraulic fluid out of the calipers, and then every time I've done brakes 100 times. I've done it in the dark. I've done it upside down. I've done it underwater. Every time I do brakes, I hit the brakes and I go, "Fuck! Why don't my brake work?" Like, every time. Anyway.
So you said for 4 hours to do all, just two?
It took about 3 hours to figure out what we were doing.
Yes, yes.
No, I'd say like if I was to come in cold, so these brakes were super wrecked. Like I've never even seen rotors this bad in all the brakes that I've done. And I would kind of guesstimate that if I was going to do like my normal whatever Toyota Corolla car that I drive every day and take good care of, if I was going to do it, I could probably do it in about 2 hours from like wheels up to wheels down for a brake job and a turn in the rotors. But there is a considerable amount of time just watching it just truck across.
It's typically like half hour, 40 minutes.
Yeah, okay,
On like a regular, even with this, it should take 1 half hour.
sure.
So they'll do a rough pass to cut quickly, and then they'll do a finishing pass. Just like these ones.
But I guess I'm curious with how rough they were. Is there any risk of getting metal left by the time you get down?
Well, so I believe that these are factory rotors. So, and I actually, with driving, I've got a 75 Oldsmobile in the parking lot that weighs 5,000 pounds, and I've done a lot of brakes on it. And I know a weird amount about brake rotor geometry just from like car ownership. And so if you buy the cheapest rotors you can find from O'Reilly's, they have, like 4 microns of steel in between, on the outside of the webbing in the rotor. But if you go to like Napa and get good quality rotors, and they put like a 1/4 inch of metal in there, and that's what these were. So there was a boatload of metal in there to work with. And then we also, because the problem is that the calipers are old and rusty and sticking, and so they're dragging funny. And so there were several times where we would have to do 3 or 4 passes on the first inch. Which way am I going to this? Yeah. So like this inner inch, we would have to do like 3 or 4 or 5 passes here before we even get into a point where we were going to tool all the way out, because they were so out of wonky. Where normally you wouldn't have to do all that.
There's a spec minimum thickness. We just measure the caliper. As long as you're over the minimum thickness.
And we were, I'll be honest with you, we're probably under the minimum thickness. I'm not too worried about it. No, we're nowhere near the webbing. Yeah, the minimum thickness is like a liability, who can sue who type of thing. So we're just gonna sue Chris.
I know you probably sometime. What was the scrap value before you started? And then what was the cost from Rock Auto for a decent pair of rotors?
Rock Auto and decent pair of rotors don't go together, first of all. And then the rotors themselves were $42 from like O'Reilly AutoZone, whatever. And then, huh? Each.
So $42.
Yeah, and O'Reilly's will spin them if they fit the meet the whatever. They'll spin them for about $20 a piece if the guy's working and the sun's out and whatever. The funny part is we had a vacuum. I don't know if it was in any of the videos. We were trying to vacuum up all this debris so it wasn't just like throwing rust and nonsense into the air. But the geometry of getting a vacuum hose in there and whatever, really didn't work. And so we had a cookie sheet, and I picked it up at the end, and it was like probably 3.5, 4 pounds of like rust and nonsense just from one of these. So that was kind of cool. Scrap value on a brake rotor is still like 38 cents.
Why can't you get 2 parallel bases on a normal lathe?
You can, it's just more horsing around to turn the outside face and flip it, and then
Why
make
would
sure
they
that
turn both bases in a single setup?
you can't get unless you're a really big blade, you can't get to the back of it. The rotors are like this big round. They're big.
Well, right, I would think you'd have an issue with swing over the bed, but if you had a lathe that was big enough to swing over the bed, or you had a removable.
You had a really big lathe and a flooring bar on the back side. But ripping it as well as part of the giant lathes. But you can turn a rotor on a lathe, but it's the amount of time that you lose. We did it in college once, which is why I know that hurt father.
Yeah.
It turned out terrible.
Well, and
We
he,
gotta figure out ways.
right, and I mess with like the Slant Pro in there all the time, and I could physically get the rotor on there, but then getting the tooling, the double-sided tooling, and like he put the fear of God in me, and like I've done enough of these goofy projects where you spend 3 days.
It's not gonna have enough travel with the boring bar all the way.
Yeah.
Yeah.
Well, and that's what I meant. You could fit it, yeah, to get all,
Something bigger than that.
yeah. Well, and that's what I have at my disposal is a couple of Slant Pros and the brake lathe that you saw in the video.
Is that steel or iron?
Cast iron.
Cast iron, okay, I was gonna say, it didn't look like it's something like steel.
Yeah, it's definitely cast.
Okay.
Yes, and it machines like cast. And you don't want to-
Yeah, it looked like it looked like it was just shearing off all over. the place.
Yeah, right. Yeah, there was no like curly cues or none of that fun
Yeah.
stuff.
Thanks, dude.
Yeah, I didn't look at the thing. I don't know if there's any
We can check to see. I was gonna say.
Zoom.
You're not off the hook yet till
Yeah.
till the Zoom people have answered. Shira must have lots of brake lathe questions. You got a brake lathe in Amherst yet? Oh,
I have to answer the question, right? Like it's funny how the question comes up about liability about cars. Like there's everything else too. There's every other kind of project here that could bring up the liability question. But whenever someone works on their car, everyone's very curious.
yeah. The car stuff's always interesting with a whole lot of regards, and that's generally here. I'll let people work on anything they want as long as it's theirs. But as soon as you're working on somebody else's car, that's where, or somebody else's thing, that's where like you have to think about what are the odds that that person's going to sue whoever is doing whatever it is that they're doing. So like Davie fixing family's car, no big deal. But if somebody wants to start working on cars as a mechanic, then they'd have to figure out liability insurance. And so like Eric Powers works on hybrid cars and he has liability insurance for doing that work as a professional. So it depends a lot. I mean, there's people here too who are like engineers, and arguably if somebody was a professional engineer here and somebody was doing engineering work here, they might be able to get sued because they technically could have overseen in some capacity what was being worked on, but like it'd be a huge stretch unless somebody was actually actively mentoring or helping with something. But I think that's present no matter what, right? You pull up to the side of the road and you help somebody start their car. What happens if the engine blows up or the car lights on fire? Like they can always sue you, right? But you are trying to be helpful, and what are the odds? It's hard to tell. Guess it depends on who has more money to start with. And the person with the broken car on the side of the road probably doesn't have more money than you do, but you never know. Anybody else have anything they wanted to share at all? Otherwise, Nick, yes. What's up? Okay, go for it. Nick's got a bicycle here, so I'll turn this around so you guys should be able to see. Let's see here.
You know, we don't have a bucket of
There you go. Take it away.
Can you hear me okay, Shira?
If you talk loudly, you will be able to. You have to be louder in those kids.
Can't hear me, raise your hand. I bought this originally as a bike that had been built as a home-built replica of a German bike called the Zox. It's front-wheel drive. Originally, there was an idler pulley here. The chain went from the crank down to the front wheel, and it's just a rocket. So it's really a blast to ride. It's so low and stretched out so straight. It's like a missile going down the road. Then in 2012, I twisted my knee a week before I was supposed to do a 400-mile bike trip. And I've been planning the trip all year. I didn't want to have to cancel it. So a friend came over and we looked at what my options were for making an arm crank bike. So we didn't have to use my one leg. And he pointed out that I had this bike with a threadless fork, and the outside diameter of that is the same as the inside diameter of the seat tube of the mountain bike. So we cut off the seat tube and the bottom bracket, and ground off the other tubes, and he welded a pinch bolt on here. And in 15 minutes, we had this set up, and I just ran the chain straight to the front wheel so that I could pedal this bike with my arms. And it was a great idea. what was an even better idea, the guy who was leading the trip asked me, "You're gonna be able to convert that back to leg power if you need to, right?" And I said, I hadn't thought about that, but yeah, all I need to do is bring a little extra length of chain, route it from this crank to this crank, to leg power bike in 5 minutes. And so after starting, I spent the whole week training on another arm cycle that a friend loaned me on paved trails in good weather with no cargo. And on Sunday, we left on the trip. I had 40 pounds of gear on the back of here. We were going uphill on a gravel trail in the rain. And in the first hour, I was 2 hours behind everybody else on normal bikes. And so I took 5 minutes. I converted it back to leg power. And nobody can keep up with me on this thing. The leg power, it's that much faster. But after the trip, what I learned was that a twisted knee injury actually benefits from bicycling because you're working all of the lateral muscles, and that helps keep your leg, immobilize your leg, so you're not twisting it. And at the end of the 400-mile ride, I was as good as new. My leg had healed. And then we spent 3 days walking around DC on pavement and hard museum floors. And I was in a wheelchair getting that into that. But I did heal eventually. Afterwards, I kept the bike in this configuration. So, I have another set of handlebars that I just bolt on here and hook up the brakes and shifting cables. And in 45 minutes, I can convert it back to a leg powered bike with regular handlebars. But I can also ride it like this under leg power. And so a couple of years ago, I repainted the bike and rebuilt it just as an arm bike. A couple of weeks ago, a friend called me and said he had injured his leg. He was going to be having surgery and he wouldn't be able to ride bikes. This is a guy that I did a 700-mile bike tour through Vermont and New York State with 40,000 feet of climbing. The guy really likes his bike, and it was really going to be a bummer not to be able to ride for 6 months. So he said, "Do you know where I can get an arm cycle?" And it was really nice to be able to answer and say, "Yeah, I've got one in my basement." And so I pulled it out. I hadn't ridden this in about 2 years. And so I've been dolling it up and shaking it down to get it ready for him. And it turned out to be so much fun that we're going to get him a separate, regular, commercially made arm cycle used. And I'll have this one to ride with him. So we can go ride together. But what I have done, I've made some upgrades to it since I've been riding it. The seat was horrible. I still have trouble. See, Saturday I rode it about 10 miles, and I still can't sit down comfortably. But I had this carbon fiber seat in my basement from another company, and so I put this on. It went right on. I had made brackets for it for another bike. The jet flying over in a second. Okay. Yeah, so I had modified, I put some brackets on this to put on another bike, and turned out that those brackets fit this frame perfectly and easily. I put some grips on the handlebars because I was getting blisters from grabbing here so hard. It's a really fun bike to ride. And I can ride it under arm power because I'm fully able-bodied. I can get in and out of it from down this low. For someone who is injured, for my friend, what we were going to do, underneath here, this is just a regular BMX bike fork, and it's pivoted here, and it has a suspension, compression, a rubber donut here for suspension. And so I can just unbolt that whole assembly and drop in an assembly that has 2 wheels to make it a trike. If I ever injure my leg again, seriously, that's what I'll do. So anyway, it was really neat how, a project that seems like it was really, really simple actually was. I think that may be the only time in my life I've ever had
you have limited right turning ability?
Not practically speaking. I mean, as soon as you turn about 5 degrees, it changes the frame,
Right.
but it doesn't derail because it's under tension on this side and it's slacking up on this side. I can turn it and still pedal it forward. What causes problems is if you try it back up while you're turning.
But so you basically can't pedal while you're turning.
You can, you just cranking it up.
Right.
But usually if you're turning that sharply, you're not putting very much power into the pedal. That's a great question.
Is there any reason you couldn't hook up both leg and arm power at the same time?
Yeah, because this chain has to twist here. And so you'd have to have 2 separate chains.
Oh, because you couldn't turn. If this one was fixed and then the back one was twisting,
Yeah,
then your chain would.
yeah. There are bikes that do have both arm and leg power simultaneously. I tried one time, it took me half an hour to learn how to ride it.
To remember which one.
It's just because you're trying to steer while your arms and legs are going around the surface. It just takes, it's not something that you can consciously learn to do. You just have to practice at it. Yeah, and you're down, and it comes to you. The scenario that I was doing this in, we were at a party, at a nighttime party after a bike rally at somebody's bike shop. And so I was the control case. I was the one who wasn't drinking. And other people were trying different levels of alcohol to stick at home. It did.
So did you weld up that frame from scratch or?
No, this is one that somebody else built. The bike, the Zox, is made in Germany and was briefly imported during the 90s. That's a couple of people in this country bought it. I have a 26-inch version of the bike that actually came from the factory. But a bunch of guys in Portland got together and made about a half a dozen at the same time. The guy who had this one decided that he didn't feel safe riding it where he has no sense of idea. A lot of people do.
Great. Thank you, Nick.
That's it. Thanks.
I'm guessing I'll talk about this. Or am I wrong?
Oh, I'm looking at it too.
Well, no, I thought you raised your hand earlier, but I could be wrong.
No, I didn't.
Oh, never mind.
Yeah, me too, that's fine.
Well, that started out as a 4x4 sheet of 12-gauge steel. And we got a silhouette of a howling coyote. This- we cut it on the plasma cutter in here, in American Controls. And then there are 3 little ones that stand behind it, and this down at the bottom is the world's largest scorpion. Although I made these for my brother who lives out in Phoenix and shipped them to him last week. And he sent me back a picture. He's got them mounted along his fence, but with the scorpion, he didn't want to bend the legs down and the stinger up because it would be a safety hazard. It's not on his fence and someone ran up against
Easier to see if you have a light.
it. Right? Oh, yeah. Yes, I am. It's fine. So the scorpion is still out against his fence.
That's easier to see.
Thank you. Well, these are the babies. I guess. they're kids.
So those are just screwed to like a wood fence or something?
The coyotes are all in the ground. I welded rebar on the bottoms of them, 2 on this one, 2 on the big one, and 1 each on the little ones. And I made a tool for him to dig holes that are just right to fit the rebar down into. Goes about 2 feet in the ground. You don't have to worry about frost in Phoenix. So 2 feet is enough.
Cool. Well, thanks, John. I didn't want to put you on the spot.
That's okay.
All
I
right.
remember, it was only a week ago.
I think that was it for presentations. I didn't hear from anybody else, so. We can go around, you can say who you are, what you're interested in, or what you do, or whatever else, and go from there. I don't know if the internet people are actually here or not. Internet people, anybody want to say anything or not? Or wave if that works too. She already presented, so.
I already did, yeah.
I don't know if anybody else probably lurking. No worries. All right. Well, I'll close up Zoom then, and I'll upload the video here in a while. If you want to share it with anybody, go for it. And thanks everybody who was able to make it online. Maybe we'll see you soon.